Actually, you didn't tell me. You paraphrased. That there's a 1 in 6 chance of getting a 1, or 1 in 6 chance of getting a 2, and a 1 in 6 chance of getting a 3. What does that mean?
You have to roll the dice 6 times, 1 of the times you get one.
I love that. I prepared such a demonstration. Thank you, Lydia. Say it again one more time, Lydia, if you don't mind.
You roll the dice 6 times, 1 of the times you get one.
Okay. So what I've got here is a spreadsheet that will speed up Lydia's experiment. What it is, this is the kind of spreadsheet I'll have you guys messing with over the back half of the course. It was going to roll dice for us. The way it rolls dice is, it randomly generates a number between 1 and 6. It's one of our one spreadsheets again. So every time you press the F9 button, you're going to see another die roll right here in this cell. That cell, if you look at that command, it says rand between 1, 6. You guys have a similar command in your TIs called rand int. You used it last week. Same thing for Excel. I'm going to go ahead and roll 6 times. There's 5 rolls. There's 6 rolls. Lydia. I see a 1. I see a 2.
5 rolls.
I see a 3. I see 2 4s. I see a 5. So what does that 1 6 mean? It can't mean that it promises us a 1 every 6 rolls. Because if it promises a 1 every 6 rolls, it should have given me a 6 as well, right? So what 2 words are we forgetting to utter with?
On average.
On average. And give me 2 more words to make me really happy. Over time. So allow us. Oh, see the 6s pop up there? So what we're going to do now is we're going to let this thing roll a little bit. Actually, I'll just stand here for a minute. I heard it was interesting. Good. I had a 105 student exclaim 2 terms ago, it's like watching evolution. And it was one of my favorite things I've ever heard in math class. Because it is like watching evolution. You're watching the evolution of where the 1/6 comes from. The 1/6 is a... Look at those pie slices now. They're not perfect. Oh, I'm going to stop right now. They're not perfect. Look at the percentages are right here. 0.15, 0.18, 0.17, 0.16, 0.16, and they're not perfect. But they're perfecter than ours. Ours were noisy after 238, but I've done it 845 times. So let's go ahead and stop it at a multiple of 200 that makes sense. Let's do a multiple of 600 that makes sense. We'll stop at 1200. And let's see how close we are visually and also how close we are numerically. Let's stop at 1200, 5, 6, 7, 8, 9. There's 1200. Theoretically speaking, how many 1s should we have seen? Exactly, if the probabilities were being observed exactly. 200, 1/6 of them were 200. We actually saw 186. That's under by 14, right? 217 2s, that's over by 17. 204, 201, over by 4, over by 1, under by 8, exact. So, we got variation. But guess what? What happens with the variation? The ones over and the ones under? Average out, they cancel to 0. You learned that 3 or 4 weeks ago. And the idea is, sure, which one's the worst one off? The 217, I think, right? That's 17 up of what it should be, but it's 17 out of 1,200 trials. That's way less than 1% error. You see what I'm getting at? What I'm getting at is, yes, you're off by 17, but that's meaningless when you have these number of trials. Look at the pie slices. What does that look like? It looks like 6 equal pieces, doesn't it? It's because the percentage error is so small as to be ignorable, if that makes sense. Fair enough? Good. So what does a 1/6 probability mean? On average over time, expect 1 success out of 6 trials. Yes. What does a 1/5 probability mean? I don't want to say that right now. On average over time, expect 1 success out of 5 trials. That's what is a point? What does a 0.14 probability mean? What does a 0.14 probability mean?
14 out of 100.
On average over time? Don't forget that.
On average over time, 14 out of 100.
Expect 14 successes out of 100. If you want to really impress friends, tell them 1 out of 7. Because that's roughly what 14% is. Roughly 1 out of 7. A lot of times people like that better. They're like 1 out of 7, 1 out of 5, 1 out of 10, 1 out of 12, things like that. Fair enough? But the important thing is the on average over time. That way we correct Lydia's, it's not a promise. I'd actually be very nervous. I've only done it 1 time in class where I went boop, 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 and I got 1 of each. Now, it can happen, correct? Any idea how rare it is for it to happen? Guesses as to how often it should happen. Once every
Blue moon.
What's a blue moon? Give me a time. Give me a number, Travis.
150.
2 blue moons? 150. Almost. One about roughly 100. It's the number is 1 in 120. You'll know why by your next project. 1 in 120 times, you should see one of each. 1 in 720 times, if you want them in order. 1, 2, 3, 4, 5, 6. That's never happened. The one I got, I was hitting on like, oh, it almost happened here. Right? We got 5 of the 6, but not the 6th. That 6th one makes it tricky. Yeah, you analyze all that in your next project. Good stuff, good stuff. Cool? So what does probability mean? It's a rate of success?
On average over time.
On average over time. Don't forget those 4 words, very, very important. All right, back to this. Speaking of averages, we'll come back to the Excel spreadsheet. I got more because they're wicked fun.